Hello everyone. Today I'm going to be introducing and instructing on orthographic drawing in AutoCAD. I'll be using AutoCAD 2018 for this tutorial, along with a few simple commands and features, such as the line command, ortho mode, object snap, and direct distance entry. If you're not already familiar with these commands, I would suggest visiting some of the links in the description regarding AutoCAD basics before watching this video. Now, to start off, I would like to define the purpose of orthographic drawing so you have a clear understanding of exactly what we will be doing today. Oftentimes, three-dimensional drawings can be used to showcase an overall concept or design, but lack clarity or detail on design specifics. See this simple drawing I have prepared to represent this. So here, you can see that we have a 3D object that have dimensioning or design features that are such as these through holes here that are difficult to see exactly where they're located, clarity as to their depth. So looking at this right here, for example, I can see that there is a hole on the front of this object. I don't know exactly where other than it is on this frontal face. I don't know how deep it goes. I can't see that from this view. The same thing with this hole on the top right here. I don't know exactly where it's located on this face, just that it's on this face. It looks to be about in the center, but I can't confirm that. Nor do I know how deep it goes. Does it go 1 inch, 2 inch? Does it go all the way through? So you can see we could use aligned dimensions and notes to explain these locations and sizes and depths, or we can use an orthographic drawing to more clearly define the design of the object. So in an orthographic drawing, we'll represent a three-dimensional object using several two-dimensional views of the object, as demonstrated here. So this will typically be done by making a front, top, and side view of an object, depending on the complexity, of course. Starting with the front view, we can use projection lines to determine the location of starting and ending points of our other viewpoints, as is shown here. Now, for simplicity's sake, we'll be using a simpler 3D shape, which I've already prepared for us, right here. So we're going to be tasked with creating an orthographic projection, which is again our front, top, and side views of the shape. So I'm going to start by creating the front view which will be shown right here by this arrow. And I choose the front view now because it's the most complicated. There is the most stuff going on the front view. Alright, so starting from the bottom left corner right here, I'm going to start my line, and I see that it is 2 inches wide. So I'm going to go 2 inches wide. I'm going to start going up now. I see that it is 6 inches from the base to the bottom of that T-like structure. So 6 inches, the bottom of the T structure is what I would call there. So this is the base. That means this line right here is 6 inches as designated by that dimension right there. Now, from here, I can see that it is 3 inches over to the left. And again, another 3 inches up to the top of that extrusion poking out from the top of the T structure. So to this little extrusion bit right here, it is 3 inches to the top of it as designated by that dimension. I see that it is 2 more inches wide, again designated by this dimension right here. And then for the line right here that goes down, I see that it is 1 inch. So 1 inch. I see that it's 4 inches from the inside edges of these two extrusions. So 4 inches. I go up again another 1 inch. To the right, 2 inches so that I'm on that outside edge. And then I'm just repeating the distances from previously. So down 3 inches, over 3 inches, and you can see that I can meet up here, but I will go ahead and input 6 inches just to make sure, and yep, it met up. So that is our front view. That is as if I were looking directly in front of this. I couldn't see any of these sides, I can't see the top, I can just see the front. Alright, so now that our front view is finished, we can go ahead and add in some projection lines to properly align our other views off of this one. So I'm going to go ahead and switch to my center line layer. And I'm going to make lines going up from each of our edges in the front view so that we can place the location of features in the top view. So I'll be starting from the left and just move to the right. And I'm going to place these lines, let's say about 8 inches above the top edge of our front view. So from here, 8 inches up. from the top edge. Alright, another 8 inches. We'll do that for each of these edges. And there are 2 more edges we shouldn't forget right here. They are the bottom. They're essentially the lines that would be going along this bottom right here. They're an edge. Now, I won't be able to see them from the top view, but we will designate them using hidden lines, which I'll show you. So again, the top view, you're pretending as though you're looking down at the given shape from above. So, as designated by this arrow, I'm looking down atop my 3D shape from above. So now that I have my projection lines, I'm going to start again from the left. So I see that it has a depth, once I go back into L1, I see that it has a depth of 2 inches, which is given right here. So that's going to be our line length. Now I'm going to draw the rest of the shape using our projection lines. So from edge to edge, I know that this is 2 inches again. Go over to here. So that's our basic rectangular shape, as is given by this. So these inside edges here should be 2 inches from the outside, but I should be able to just use my projection lines. Now these inside edges on the bottom part of that T, I can't actually see from my top view. So when I put these lines in here, I'm going to go ahead, select them, and set them to the hidden line layer. This will represent that they are beneath this top view. They are happening beneath this top view. I can't see them, so they are hidden. Now I'm going to go ahead and double check the line lengths. So I'm going to check my distances using my distance command. This representing the top extrusion is 2 inches. The outside edge to the inside, which is this distance right here, that outside to this inside of the bottom is 3 inches. I can go ahead and double check that, as we saw, was 3 inches. The total length is 8 inches. This length is 6 inches, which is again from this outside edge to this inside edge right here. So that should be 2 plus 4, which is 6, just like we expected. I can check this. It is 2 inches, like we thought. And finally, let us check. This is 2 inches, so that is this distance right here, or this distance. It's all the same. So we've checked our top view. The lines all appear to be the correct length. So we have our top view. It's done. Let's go ahead and move to the side view now. Now to start off, I'm going to go ahead, select all these projection lines, and I would highly suggest moving them out of the way. If you feel like it's getting too crowded, it's getting in your way, just temporarily move them out of the way. Let's move them 12 inches out. Alright, we can move them back once we're finished, because we're going to go ahead and create more projection lines now from these edges. So let's actually start from this outside edge here and go 8 inches again. We'll say 8 inches from each one of these edges, alright? So here we go. And then finally, we have this point right here. This is another edge happening that we will be seeing on our side view, and it's going to be our right side, as is shown by this arrow right here. So as if I were taking this arrow and just stepping to the side of the shape, so that I couldn't see the front views, the top views, or anything, just the side. So what would I see from that perspective? Well, we're going to go back into L1, and again, we're starting with our depth here, our depth. So I know that it is 2 inches deep. It is 2 inches wide at this point. Now I'm going to go up. I see that my total distance is 9 inches, which should match up with our projection lines here, which it does. Again, another 2 inches, and I go down 9 inches. I think this is the easiest way to start the construction of it. I have these 4 lines right here, which is the total outside shape as indicated right here. There's my rectangle that I just drew. Now I need to get this line right here, which I know is 6 inches, because it is the same as on this side. So this line right here, I can follow this projection line. It is 6 inches from the base, which we can check now. 6 inches. All right. Finally, we got to draw this inside edge line, which I can't see. It would be the line going like this, or this line. I can't actually see that from the right side. So when I draw this line, I am going to select it and again place it on a hidden layer, and we will adjust the line type scale, make it a little bit easier to see. So this line right here indicates that I can't see it. Now, and again, we know that it has 1 inch, and we can again just check our distances very quickly. So that is 1 inch. It should be, this line right here should be 3 inches, which it is. The total is 9 inches. So everything is checking out. We'll just check this, 2 inches again. It's the same thing. We've found them all. Now let's go ahead, and that's our entire right view. That's everything we're seeing from our right side. We're going to move our top projection lines back over again, another 12 inches. And this is our orthographic view right here. So, in summary, we have discussed the purposes and uses of our orthographic drawings and projections. We've made our own projection of a simple shape so that it can be read and understood more easily. Finally, I will say that you should always dimension your 2D views of the object, like I've demonstrated right here. So rather than cluttering up this 3D object, we have placed our dimensions where they're more easy to read in these 2-dimensional views. It's more easy to tell what's going on and look at these orthographic projections and get a clear understanding of what's happening in this 3D view of it. So again, less cluttered, more easily understood, and it helps to locate design features more readily than a 3D drawing could. However, we're not going to cover how to do all of that in this video. To see examples on how to do these dimensionings correctly, we'll make a future video on how to properly annotate your drawings. That's it today, everyone. Thanks for joining me, and I'll see you in the next video.